Hello, and thanks for your continued interest in the subject of shaft alignment. This tutorial on preliminary alignment checks and corrective measures will discuss information that will hopefully assist anyone who is responsible for installing or maintaining rotating machinery, for people who evaluate the operational or mechanical performance of machinery, and for technicians and engineers who are responsible for rotating equipment. So, this information is intended for trades personnel, maintenance supervisors, training instructors, mechanical procedure writers, vibration analysts, engineers, maintenance managers, and any interested operations personnel. The major topics in this tutorial will discuss the issues that can arise when attaching external connections to our rotating equipment and how to determine if external connections such as piping, ductwork, or conduit is inducing excessive forces and stresses into our machinery. A lot of our machinery has piping, ductwork, or conduit attached to it. These external connections, if installed improperly, can induce stresses into our machinery that can, over time, shift the equipment out of alignment. I know this has probably never happened to you, but I have seen piping so far out of alignment that people have taken chain falls, attached one end of the chain fall to the pipe and the other end to a building column, and pulled a pipe into position. If you ask the manufacturers of the machines, the flanges on our pumps and steam turbines are fluid connection points. They were never designed to be piping anchors. Our piping should be installed and supported so there is very little static or operating forces being induced into the machinery. I'm not sure what people want me to say about this. If our piping is misaligned by 2 or 3 inches, you are going to have to cut and refit the pipe. If the piping is somewhat close to being aligned but off by less than 1/4 of an inch, there are ways we can possibly account for this when aligning the machinery. Dealing with small amounts of piping fitter problems will be addressed in the intermediate alignment tutorials. When pipes are attached to machinery, you cannot visually see if there is an excessive amount of piping stress present. Prior to attaching, say, the suction and discharge pipes on a pump, one way to check for excessive piping stress is to rough or final align the machines. Attach brackets to one of the shafts, span across the coupling, and place a dial indicator on the top and another indicator on the side of the other shaft. Plunge the indicators in a little bit and zero the indicators. If you only have one bracket and one indicator, set the bracket and indicator off on a 45-degree angle. You could also set up some magnetic bases on the base plate and indicators on the pump casing at the inboard and outboard ends to monitor any movement. Then, begin attaching your pipes and every once in a while check the indicators to see if you are moving the pump out of alignment. If, after finishing the piping attachments and the indicators still read 0, the ultimate test is to then loosen all the foot bolts on the pump. If, after loosening the foot bolts, you don't see any more than 3 to 4 mils of movement in any direction, then there is probably an acceptable amount of static piping stress. Static piping stress is defined as the amount of stress induced into the machinery when it's not running. Dynamic piping stress is defined as the amount of stress induced in the machinery when it is running. Bear in mind that some of our machinery is flowing hot process fluids. Metal expands when it gets hot and may therefore move enough to induce loads when the equipment is operating. Dynamic piping forces are extremely difficult to measure. Come to think of it, I don't know anyone who's ever tried to measure it. If piping expansion does occur when running, the machinery might have a chance of not moving, assuming we had no static piping stresses to begin with. Here's a multi-stage pump where we did the static piping stress test in reverse. After the unit had been offline for over a week, we attached some brackets on the motor shaft and placed indicators on the pump shaft. We also set up some magnetic bases and indicators to monitor any lateral movement at the bolting planes. When we loosened the inboard bolts, the pump raised up about 20 mils at the coupling. We then removed the suction flange bolts and removed the suction pipe, and the pump moved sideways about 6 mils. We then loosened the outboard foot bolts, and the pump moved further upwards 80 mils and sideways about 30 mils. At this point, only the discharge pipe was attached. We then loosened the discharge flange bolts, and the pump dropped back down and set on the base plate. We then measured the gap at the discharge flange faces, kept notes, and discussed how we were going to correct this. Since the gaps were not excessive, we decided to alter the alignment correction moves to not only align the shafts, but also fix the piping fit-up problem. This will be discussed further in one of the intermediate alignment tutorials. Well-designed foundations will last for decades. Some of our rotating machinery is located inside of buildings that is climate controlled, and some of our rotating machinery is outdoors exposed to Mother Nature. When our concrete foundations, cement-based grout, and steel base plates or sole plates are exposed to rain, snow, intense solar heat, and vibration from the machinery, eventually the foundation deteriorates. When anchor bolts begin to rust or break, the grout begins to crack and chip away, and the base plate is no longer in a stable position, it is probably time to consider removing the machinery and installing a new foundation. It is up to us to periodically observe this deterioration and make an informed decision on when foundation repairs or replacement is warranted. It doesn't make much sense aligning machinery that should be repaired or replaced. Vibration analysis can help us understand what problems we have with our machinery so we can pinpoint the defective components and replace only what is failing. Prior to aligning rotating machinery, we need to ensure that coupling hubs are bored properly and the shafts are not permanently bent. Shaft alignment is the process of aligning center lines of rotation. Many alignment measurement tools are incapable of measuring runout. You can't just hope that you don't have a runout problem. You really need to verify it. Sawfoot problems are far more prevalent than people realize, and the gaps that exist under our machinery feet are complex wedge-shaped gaps that cannot be fixed with flat pieces of shim stock. Sawfoot is not discriminatory. It occurs on motors, turbines, pumps, fans, generators, gearboxes, and pillow block bearings. Again, anytime you attempt to mate one surface to another, there is a possibility of poor contact. It's not easy to fix, but it's very easy to ignore. Piping can have a huge influence on the alignment and positional stability of our rotating machinery. Proper piping fit-up is critically important, and even though pipe fitters may not be responsible for aligning machinery, they need to know how their pipes can wreak havoc on our desire to keep machinery aligned for long periods of time. Piping anchors may need to be added to ensure no, or at least very little piping strain impinges on our equipment.